Okay, okay. So I'm audible, right? And the PPT is visible clearly.
Yes, sir.
Okay, so Vaishnavi, were you present in the last Sunday's lecture, last Sunday's problem solving session?
No, sorry, sir. I didn't see the email, so I'm attending the
Okay,
lecture
okay,
first time.
okay. No, no issues, no issues. So I'll just give you some introduction on the course content. Okay. I'll just give you the introduction of
Yes,
the
sir.
course content and what we are going to do, what we generally do in this kind of live interactive sessions. Just a minute. Yeah, what we generally the plan. What is the plan of this interactive session and what is the motive of this interactive sessions? Okay, so you all attend the classes, I believe, of the NPTEL course Soil Mechanics Geotechnical Engineering 1, isn't it?
Yes, sir.
Yes, so this sessions is solely dedicated to the problem solving part. Okay, like each and every week, this is a 12-week course, and each and every week has a particular topic. And in these sessions, uh, we will be solving some problems. The problems can be MCQ or MSQ, true false statement, or numericals. Okay, the problems can be MCQ, MSQ, true false statement, and numericals. Okay, and in these problem solving sessions, as I have already said in the last class, but you are absent, it will be like what to say, better if you can make this session a bit interactive. So what I generally do, I have a set of questions, MCQ, MSQ, true false, and numericals. I first dictate those questions. Okay, even today also I'll first dictate all those questions to you. You write down all those questions along with the options. You take out your uh, copy, pen, and a calculator. Okay, after dictating all the questions, I will give you some time, around 15 minutes on an average, to solve all the questions. After 15 minutes, I will then start discussing the answers. So those questions which you have solved, you will be explaining the logic behind your solutions, and if you can't solve this, I'll be explaining the answers to you. Is it clear? I hope it is clear, everyone.
Yes, sir.
Yeah, okay. So I'll be starting now right away to to dictate the questions. You all please write down the questions one by one, okay? And no need to tell the answers right now, okay? I'll give you some time to solve these questions. After that, I'll be asking you and we'll be discussing the answers. Okay. So the first question. So today's topic is the second week's topic of soil mechanics and geotechnical engineering 1. The topic is three-phase diagram and weight volume relationship. All right. So by the word three-phase diagram, I hope you have known the fact that soil is composed of three phases: solid, liquid, and air. Okay. So this entire uh, live session is going to be dedicated to the weight volume relationship of the soil and the basic index properties and some numericals with respect to these concepts. Okay, so the first question of today's lecture is what is degree of saturation? What is degree of saturation? Your options are moisture content of soil mass in its natural state, ratio of volume of water in a soil mass to the volume of soil solids, ratio of volume of water in a soil mass to the total volume of voids in it. Option 4, moisture content of soil mass in its saturated state. You have to find out the right option. Okay, what is the definition of degree of saturation. I repeat the question once again. What is degree of saturation? Your options are moisture content of soil mass in its natural state, ratio of volume of water in a soil mass to the volume of soil solids, ratio of volume of water in a soil mass to the total volume of voids in it. Option 4, moisture content of soil mass in its saturated state. I hope you have written the question. I'll go to the next question now. The second question, it is the relative ease with which a soil mass can be deformed is termed as. Relative ease with which a soil mass can be deformed is termed as. Your options are toughness, compressibility, consistency, sensitivity. I'll repeat the question once. Relative ease with which a soil mass can be deformed is termed as. Your options are toughness, compressibility, consistency, or sensitivity. I'll go to the next question. Someone has joined, I think. Okay, those who are joining late, please, I'm dictating the I'm dictating some questions. Please write down the questions first, and I'll give you some time to solve the answers, solve the questions. After 15 minutes, I'll then start discussing the answers. Okay, write the questions now. Okay, next question. The term density index is not applicable to cohesive soils because. The term density index is not applicable to cohesive soils because. Your options are: it is difficult to obtain particle size gradation. Option 2 is uncertainties in determining void ratio in the natural state. Option 3, uncertainties in determining void ratio in the loosest state. Option 4, uncertainties in determining void ratio in the densest state. I'll repeat the question. The term density index is not applicable to cohesive soils because. Option 1, it is difficult to obtain particle size gradation. Option 2, uncertainties in determining void ratio in the natural state. Option 3, uncertainties in determining void ratio in the loosest state. Option 4, uncertainties in determining void ratio in the densest state. Next question. Percentage voids is another term for. If you tell me what is the another term for percentage voids, the options are percentage air voids, void ratio, degree of saturation, or porosity. Percentage voids is another term for. The options are percentage air voids, void ratio, degree of saturation, or porosity. Those who have joined late, there is no need to write the answers in the chat box. Please do not write the answers in the chat box, whether right or wrong. You first write down the questions as I dictate. Write down the questions and the options. I'll give you some time, around 15 minutes, to solve all the questions because there are some numericals also. After that time, we will be discussing all the answers. Okay. Percentage voids is another term for. The options are percentage air voids, void ratio, degree of saturation, or porosity. Next question. Coefficient of uniformity is a measure of. Coefficient of uniformity is a measure of. Your options are shape of the particle size distribution curve, percentage of fines in any soil mass, plasticity index, or particle size range. I'll repeat the question. Coefficient of uniformity is a measure of. The options are shape of the particle size distribution curve, percentage of fines in any soil mass, plasticity index, or particle size range. I go to the next question. For people who have joined late, I'll just repeat this question. Coefficient of uniformity is a measure of. The options were shape of the particle size distribution curve, percentage of fines in any soil mass, plasticity index, and particle size range. Next question. The maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. Please write the question very carefully. The maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. You have to answer at which maximum water content the reduction in volume or the increment in volume will stop with the change in moisture content. Your options are liquid limit, shrinkage limit, plasticity index, or plastic limit. I'll repeat the question. The maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. Your options are liquid limit, shrinkage limit, plasticity index, or plastic limit. Next question. Addition of consistency index and liquidity index yields a value of. Addition of consistency index and liquidity index yields a value of. Your options are 0, 4, 1 and 2. I'll repeat the question. Addition of consistency index and liquidity index yields a value of. What do we get when we add consistency and liquidity index of the soil, of any particular soil? Please keep in mind that consistency index and liquidity index will be evaluated for one particular type of soil, and for that specific soil, if we get these two values, then on addition, what shall we get? So this is the question. Addition of consistency index and liquidity index yields a value of. Your options are 0, 4, 1 and 2. Next question. When the percentage voids is 34%, what is the void ratio of the soil? Previously there was a question regarding the percentage voids. What is its other name? Now if you find out the other name, then with that the value given over here is 34%. Then using that, how can you determine the void ratio of the soil? So when percentage void is given, what will be the void ratio of the soil? Your options are, for 34% of this soil of, of percentage voids, your options are 0.623, 1.204, 0.515 or none of these. I'll repeat the question once. When the percentage voids is 34%, what is the void ratio of the soil? Your options are 0.623, 1.204, 0.515 or none of these. For those who have joined late, please write down the questions. I'll give you time to solve these questions and then we'll discuss afterwards. After you solve the questions, we'll discuss them. Okay. Okay, I'll go to the next question. This is a true false statement. A soil is said to be uniformly graded when it has a good representation of particles of all sizes. A soil is said to be uniformly graded when it has a good representation of particles of all sizes. To answer me whether this statement is true or false. I'll repeat the question once. A soil is said to be uniformly graded when it has a good representation of particles of all sizes. Is this statement true or false? Next question. The Casagrande's apparatus is used for determination of. I hope you know what the Casagrande's apparatus is. So, with that apparatus, which index property of soil we generally determine in the laboratory? Your options are liquid limit, shrinkage limit, consistency index, or plastic limit. The Casagrande's apparatus is used for determination of liquid limit, shrinkage limit, consistency index, or plastic limit. Next question. Another numerical. A soil mass compacted at a moisture content of 12% has a bulk unit weight of 18.73 kilonewton per meter cube. Its dry unit weight in kilonewton per meter cube is. Please write down the data very carefully. That is a 12% moisture content and the bulk unit weight of 18.73 kilonewton per meter cube. Your options are 15.98, 21.34, 15.87, 16.72. I'll repeat the question once. A soil mass compacted at a moisture content of 12% has a bulk unit weight of 18.73 kilonewton per meter cube. Its dry unit weight in kilonewton per meter cube is. Your options are 15.98, 21.34, 15.87, 16.72. I'll go to the next question. Another true false statement. A temperature of 105 to 110 degrees centigrade needs to be maintained for oven. This is oven actually, not over. Oven drying method of water content determination. A temperature of 105 to 110 degrees centigrade needs to be maintained for oven drying method of water content determination. Is this statement true or false? And along with it, I'll be asking you what will happen if the temperature is less than 105 degrees centigrade and what will happen if the temperature is more than 110 degrees centigrade. Okay, if this is true, then what will happen if it goes beyond the prescribed range, and if it is false, then what is the actually prescribed range? Okay, so just answering true and false will not help, because you have to tell me if this is false, then what is the prescribed range and what will happen if it goes beyond the prescribed range. Is it clear? Is the question clear?
Yes, sir.
Yeah, okay. So a temperature of 105 to 110 degrees centigrade needs to be maintained for oven drying method of water content determination. Is this statement true or false? Next question. Flow index is. What is the definition of flow index? Measure of particle flow after complete saturation, degree of stiffness after reduction in moisture content, slope of the flow curve in liquid limit test, or difference between liquid limit and plastic limit. Flow index is, the options are measure of particle flow after complete saturation, option 2 degree of stiffness after reduction in moisture content, option 3 slope of the flow curve in liquid limit test, option 4 difference between liquid limit and plastic limit. Next question, another numerical. This is actually a conceptual numerical. In a wet soil mass, air occupies 1/6 of its volume and water occupies 1/3 of its volume. The void ratio of the soil is. Your options are 0.25, 1, 0.5, or 1.25. I'll repeat the question a bit. In a wet soil mass, air occupies 1/6 of its volume. Its volume, that means the entire soil volume. And water occupies 1/3 of its volume. So 1/6 is occupied by air and 1/3 is occupied by water. Then what is the void ratio of the soil? Your options are 0.25, 1, 0.5, or 1.25. And go to the next question. A soil deposit has a void ratio of 1. Another numerical. A soil deposit has a void ratio of 1. If the void ratio is reduced to 0.6 by compaction, the percentage loss in volume is. Loss in volume means not the soil storage but the entire soil volume, entire volume of the soil mass. I'll repeat the question. A soil deposit has a void ratio of 1. If the void ratio is reduced to 0.6 by compaction, the percentage loss in volume is. Your options are 10, 20, 30, or 40 in percentage. A soil deposit has a void ratio of 1 if the void ratio is reduced to 0.6 by compaction. The percentage loss in volume is 10%, 20%, 30% or 40%. Next question. Which of the following is constant for a given soil? I have mentioned some of the index properties of soil, basic engineering properties or physical properties of soil. Which of these properties will be constant for a given soil mass? And by constant I mean obviously with respect to any change in its moisture content or any change in its volume due to moisture content increment or decrement. Whatever happens, which of these properties will remain unchanged? Sorry. Options are bulk unit weight of solids, dry unit weight, or saturated unit weight. Which of the following is constant for a given soil? Bulk unit weight of solids, dry unit weight, or saturated unit weight? Next question. Find the porosity of a soil whose void ratio is 0.5. Find the porosity of a soil whose void ratio is 0.5. There is a basic relationship between void ratio and porosity. So what will be the porosity when there is a certain given value of void ratio? In this case your options are 0.5, 1, 1.333 or 0.333. Find the porosity of a soil whose void ratio is 0.5. The options are 0.5, 1, 1.333, 0.333. Next question. Another numerical. For a soil in natural state, void ratio is 1. Water content is 30% and specific gravity is 2.50. The degree of saturation in percentage is. For a soil in natural state, void ratio is 1, water content is 30% and specific gravity is 2.5. The degree of saturation in percentage is. Your options are 0, 100, 40, or 75? I'll repeat the question once. For a soil in its natural state, void ratio is 1, water content is 30%, specific gravity is 2.50. The degree of saturation in percentage is 0 or 100, 40 or 75. Next question. Theoretically, the void ratio in soils can have the following values: more than 1, can be less than or more than 1, less than 0.5, or less than 1 only. Theoretically, the void ratio in soils can have the following values: more than 1, can be less than or more than 1, less than 0.5, or less than 1 only. I go to the next question. A soil sample of mass 0.18 kg having a volume of 10 to the power minus 4 meter cube is mixed with 0.02 kgs of water. Its dry density is 1600 kg per meter cube. The initial and final water content in percentage is. I have asked you the initial and the final moisture content. That is, initial means before addition of 0.02 kgs of water, and final means after the addition of 0.02 kgs of water. Okay. Given its dry density is 1600 kg per meter cube. Your options are 10 and 20, 12.5 and 25, 2.5 and 5, or 15 and 30. I'll repeat the question. A soil sample of mass 0.18 kg having a volume of 10 to the power minus 4 meter cube is mixed with 0.02 kgs of water. Its dry density is 1600 kg per meter cube. The initial and final water content in percentage is 10 and 20, 12.5 and 25, 2.5 and 5, or 15 and 30. Next question. A particle size distribution curve with a flat portion represents. I hope you know what a particle size distribution curve is. In that curve, if you get a graph with a flat portion, then what does that graph represents? Your options are uniformly graded soil, well graded soil, gap graded soil, or poorly graded soil. A particle size distribution curve with a flat portion represents uniformly graded soil, well graded soil, gap graded soil, or poorly graded soil. Okay. Next question. This is linked question. These two sums have the same question with two different questions. Same statement with two different questions. Okay. Please write down the data very carefully. A cube of dried clay having sides 5 centimeter long weighs 135 kg. Sorry, gram. A cube of dried clay having sides 5 centimeter long weighs 135 grams. The same cube of soil, when saturated at unchanged volume, weighs 195 gram. Please read the question very carefully. The same cube of soil, when saturated at unchanged volume, weighs 195 gram. In this case, you have to find out firstly the specific gravity of the soil. Your options are 2.652, 1.968, 2.067, or 2.077. The same statement will be useful for another question. What will be the void ratio of this soil? You first have to find out the specific gravity of the soil and then find out the void ratio of the soil. Or you can do what to say, vice versa. First and second, whatever you want to do. The void ratio of the soil is, the options are 0.468, 0.932, 0.789, or 0.923. I'll repeat the question. A cube of dried clay having sides 5 centimeter long weighs 135 gram. The same cube of soil, when saturated at unchanged volume, weighs 195 gram. To find out the specific gravity and the void ratio of the soil. Okay. So that was all the questions. uh, I'll give you 15 minutes of time. I'll start at 6. Okay, you solve this question, and from 6 o'clock we'll be discussing the answers. And please stay in the meeting. Okay, don't leave the meeting, stay in the meeting. Someone has joined right now, but the class has been started from 5 o'clock. I have already dictated the questions. You can wait. The others will be solving the questions right now, and after 15 minutes from 6 o'clock I will be starting to discuss the answers. Okay, please finish the solutions by 6 o'clock. I hope the screen is visible and I'm audible. Hello.
Yes, sir.
Yeah. Okay. So I hope you have completed the solving the questions. I'll be now discussing the answers. Okay. Someone else also joined. Fine. Okay. So the first question was, what is degree of saturation? Isn't it? So what is the answer to the first question?
Volume of water to volume of voids.
Volume of water to the volume of voids. Right. Degree of saturation we write like this: S equals to volume of water in the soil to the volume of voids in the soil expressed as percentage. Okay. So it is, the definition is the the voids in the soil, how much of the void is occupied by water, that is the degree of saturation. So yes, option C is correct. Ratio of the volume of water in a soil mass to the total volume of voids in it. Okay. This is called the degree of saturation. Good. The next question was, relative ease with which a soil mass can be deformed is termed as. What is the answer?
Consistency.
Yes, consistency. But in that case, you have to define the other three what is it, terms. Do you know the definition of the other three terms?
So in general, I can explain.
Yes. So what is toughness?
It's a resistance property of a soil to deform.
Yes, not to deform. It is resistance to deformation. Okay, resistance to deformation. Any resistive action against the deformation or the deformative force in the soil is called toughness. Okay. What is compressibility?
Force act on the soil reduces.
Yes. What?
When any external force acts on the soil, its volume decreases.
Yes. The capacity by which, the property by which the volume of a soil decreases on the application of external force is called compressibility. And what is sensitivity?
I don't know about it.
Sensitivity is nothing but the degree of disturbance in a soil mass due to any externally applied force. The degree of disturbance, or in general case, when we mold the soil, molding and remolding of soil, there is a certain degree of disturbance. That degree of disturbance is called sensitivity. And consistency is, yes, the relative ease with which a soil mass can be deformed is termed as consistency. And this deformation in the soil mass, that is the consistency limits which we call as liquid limit, plastic limit, and shrinkage limit. These are the consistency indexes, consistency limits. So yes, the property by which the soil can be deformed, the relative ease of which is called consistency. Very good. Okay. So next question, third question. The term density index is not applicable to cohesive soils because any answer? If you don't know, you can say no. I'll just start explaining the answer.
So please explain.
Okay. So what happened? What is the definition of density index? First, you have to know that density index, if you write as ID, is equals to E max minus E. I'll just check once. Is E max minus E. Yes, E max minus E divided by E max minus E min. Now E, you know that it is void ratio, right? E max, what is E max? Maximum void ratio. It means what? The soil is in its loosest state. E means natural void ratio in the natural state. And E mean is what? That is the lowest void ratio. That is the void ratio in the densest state. So in the case of cohesive soils in the laboratory, what happens is this E max, it is very difficult to obtain for cohesive soil. That is a void ratio in the loosest state, because cohesive soils have a property called cohesion, soil cohesion, because of which the loosest state is very difficult to obtain for cohesive soil. Cohesion is absent in granular soil, hence Emax is readily, what to say, it can be very easily found out in case of the granular soils or the cohesionless soils like sands and gravels. But in case of cohesive soil, because of cohesion, this Emax is very difficult to find out. There will be many uncertainties involved in it. Hence, density index is not applicable to the cohesive soil. It's applicable only for the granular soil or the cohesionless soil like sand and gravels. So, it is not applicable because the uncertainties in determining void ratio in the loosest state, that is Emax. Is it clear?
Yes, sir.
Yeah. So in the laboratory, Emax is very difficult to find, and if it at all can be found out, there will be many uncertainties attached to it. So it is better to avoid this term for the cohesive soils. Okay. Yes, Emax loose state. Okay. Next question. Percentage voids is another term for, what is the answer?
Porosity.
Yes, porosity. What is percentage air voids? What is percentage air voids? You know? Okay, no problem. It is the volume of air divided by the total volume into 100. Volume of air or volume of air voids, same thing. It is percentage air voids. What is void ratio? What is void ratio?
Volume of void upon volume of solid.
Yes, VV by VS. This one we have already covered, degree of saturation. What is porosity? Porosity N equals to volume of what? Hello. Definition of porosity?
Volume of void upon total volume.
Yes, volume of voids upon total volume of soil mass, and porosity, unlike void ratio, is expressed as percentage. You can write the fraction in numericals, but it is represented in general as percentage. So yes, percentage voids is another term for porosity. Okay. Next question. Coefficient of uniformity is a measure of, what is the answer?
Particle size ratio.
Particle size range. Particle size range or ratio. It is range over here. You see, during sieve analysis or particle size gradation, we have two different type of what to say coefficients. One is the coefficient of uniformity, and here is the coefficient of curvature, right? Coefficient
Yes,
of
sir.
uniformity is the formula of d60 by d10, isn't it? d60 upon d10, and this is coefficient of curvature is d30. What is the formula?
30.
30 whole square, right?
Yes, sir.
Divided by d60 into
Into detail.
d10. Very good. So maximum, and what is d60 and d10? d60 is size range such that 60% of particles are finer than this size. This size range such that 10% of particles are finer than this size. So this ratio, this d60 by d10, it tells us about the range of the particle size present in the particular soil sample. Okay, so Cu, coefficient of uniformity, is a measure of the particle size range. Okay, now what is Cc? Cc gives us the shape of the particle size distribution curve. Okay, what is the shape? It will be S shaped, it will be uniformly graded, straight line, gap graded, horizontal line. That is given by Cc. Okay, because it has one more particle size with it, d30. So it will give a better view of the graph which we plot. Okay, but in general the particle size range will be given by coefficient of uniformity or Cu. Okay, I hope it was clear. Okay, next question. The maximum water content at which a reduction in water content will not cause a decrease in the volume of soil mass. What is the answer?
Shrinkage limit.
Yes, shrinkage limit. What is plasticity index then?
The shrinkage limit minus plastic or something. Plastic limit.
No, no, no. Think. See this graph. If you remember this graph, you won't make that mistake. What what is happening in this graph?
Plastic limit minus shrinkage.
No. See what?
Water content.
No, no, no. See what is happening in this graph. If we go from the right to the left, I'm going from A to B and then to C. Okay. If I go from A to B, what is happening? The moisture content is decreasing, right? Towards the left. And as the moisture content is decreasing, what is happening? The volume is also decreasing, but up till a certain point, up till B. After this, even if we decrease the moisture content, the volume is constant. That means the soil has a certain voids. Okay, the water was initially filling beyond the voids. Now after point B, only the voids is occupied by water, and hence the soil mass has reached its optimum or minimum volume with respect to the decrease in moisture content. So this B point is called WS or shrinkage limit. What is plasticity index? Plasticity index is the range within which the soil remains in the plastic state. This is the plastic state. So this range is, which is more? WL is more than WP, right? Liquid limit is more than plastic limit. So difference in liquid limit and plastic limit, WL minus WP gives us the plasticity index. Plasticity index is WL. Plasticity index is, I'll write liquid limit like this, liquid limit minus plastic limit. Okay, liquid limit you all know, this is the liquid limit after which if we go on adding water after liquid limit, the soil will behave like a liquid. Okay, the soil will behave like a liquid. That is the liquid limit. What is plastic limit? Range of soil, what to say, the point after which the soil will stop behaving like a plastic material or easily deformable material and will go to a semi-solid or stiff stage. Okay, this is called plastic limit. Okay, is it clear?
Yes, sir.
Yeah. So I hope you have got the definition of plasticity index and the significance of the answer of this question is shrinkage limit. Okay. So this graph is very important. If you remember this graph, have a clear vision, have a clear what you say picture of this graph in your mind, you will never forget the definitions. Next question. Addition of consistency index and liquidity index yields a value of, what is the answer?
I don't know.
Okay. Yes, you should tell. If you don't know, you should not just keep silent. I can just start explaining the solution. Okay. So you have to first know what is consistency index and what is liquidity index. What is consistency index? The definition is, I write WL minus WL minus W by IP. What is liquidity index? W minus WP divided by IP. What is IP? IP is the plasticity index, that is liquid limit minus plastic limit. What is WL? WL is the liquid limit. What is WP? WP is the plastic limit. What is W? W is the natural moisture content of the soil. Now if you just look at this graph, the previous graph, IC is WL minus W. WL, we are subtracting W from WL, that is how much it is deviating from the liquid limit that is being considered by the consistency index. So if we say the value is positive, that means the moisture content is less than the liquid limit. Okay. Now what is liquidity index? W minus WP. W minus WP. It is considering whether it is higher or lower than this plastic limit. If it is positive, that means W minus WP is positive. That is W is more than WP. That is it is more than the plastic limit. Now if we add these two, then what will we get? IC plus IL equals to WL minus W plus W minus WP, isn't it? Divided by IP. Now this minus W plus W gets cancelled. What we get in the numerator? WL minus WP. What is WL minus WP? What is the definition of liquid limit and plastic limit difference? I just said in the previous question, WL minus WP, liquid limit and plastic limit. What is it called? Hello?
Yes, sir.
Yes. So, could you follow the explanation? Hello? Could you
No,
follow?
sir, the voice was not clear.
Okay. Is it clear now?
Yes, sir.
Yes. So this is the definition of consistency index and liquidity index. Now if we add consistency index and liquidity index, the numerator is WL minus WP. What is WL minus WP? What is it called? What is WL? WL is the liquid limit. WP is the plastic limit. Liquid limit minus plastic limit. What is it called? Hello? Liquid limit minus plastic limit. What is it called? I have mentioned in the previous question. Okay, it is called,
Plasticity index.
yes, it is called plasticity index. So if we get plasticity index in the numerator and plasticity index in the denominator, which gives us a value of 1. Clear?
Yes, sir.
Okay. So you just go through these concepts of concepts of consistency index and liquidity index once more. Okay, it will be clear from any what to say prescribed textbooks like BC Punmia or Gopal Ranjan Rao, any book. Okay, you can follow BC Punmia. It is given in a very concise way. Okay, next question. When the percentage void is 34 percentage, what is the void ratio? Percentage void means what? Have you solved this question?
Yes, sir.
Okay, so what is the answer?
0.515.
Yes, very good. 0.515. So percentage voice means porosity. Porosity is n. I'll write like this. If it is 34%, that is 0.34, because I have to find the void ratio in decimal. What is the formula? E is equals to how much?
0.34 upon 1 minus 0.34.
Yes, E is equals to n by 1 minus n. E is equals to n by 1 minus n. You put the value of 0.34, you get 0.515. So void ratio equals to porosity by 1 minus porosity in fraction. Okay. Okay, easy question. Next question. A soil is said to be uniformly graded when it has a good representation of particles of all sizes. True or false?
True.
True.
Yes, sir.
What is the difference between uniformly graded and well graded soil?
Sorry, sir. It's false.
Yes. What is uniformly graded soil?
When it contains the particle of size
Particle of,
or equal size.
yes, particles of all equal size is present. It is called uniformly graded soil. It is not a good soil actually. It is a bad soil. Can you tell me why it is a bad soil? Why uniformly graded soil is called a poorly graded soil?
So because all the same size, the would not be filled other particle. It will contain voids in
Yes,
between them.
yes, yes, very good. Because of the same sizes, the voids will not be filled up. There will be lack of interlocking force between the in the voids because of the particles size being the same. So, well graded soil, it has a good representation of particles of all size, not a uniformly graded soil. Okay, so this is false. Okay, next question. The Casagrande apparatus is used for,
Liquid limit determination.
yes, liquid limit determination of soil. Number of blows we give to the instrument either manually or mechanically, and after after the what to say the gap closes, that is the moisture content, we note and we plot a graph to find the moisture content at 25 number of blows from the graph, isn't it? I'll be coming to this graph next question also. Okay. Okay. Soil mass compacted at a moisture content of 12 percentage has a bulk unit weight of 18.73 kilonewton per meter cube. Its dry unit weight is how much?
So don't.
Huh? Don't know. Hello.
Yes, sir.
Okay, no problem. If you don't know, no problem. So what is the formula for dry unit weight? Gamma D is equals to gamma divided by 1 plus W.
W.
If you know the formula, you can solve this question. Okay. Gamma is the bulk unit weight. W is the moisture content is 0.12. You put the value and tell me the answer now.
Yes, sir.
Yes. What is the answer? 18.73 divided by 1 plus 0.12. Yes. What is the answer?
16.72.
Yes, 16.72. Option D. Last option, isn't it? So yes, don't forget this formula. It is very important to find out the dry unit weight from the bulk unit weight. Okay. Next question. A temperature of 105 to 110 degrees centigrade needs to be maintained for oven drying method of water content determination. True or false?
True.
True. Okay. So what will happen if it is less than 105?
So complete evaporation will not take place.
Exactly. And what will happen if it is more than 110?
The water means that crystallization water which is present in the soil particles, it will start losing its bond in between the
Yes,
particles.
yes. So crystalline structure of the soil will be damaged. It will lead to the release of the chemically bonded water with the soil particles. Okay, we don't want to lose the chemically bonded water. We have to lose the superficial water, water in the voids only. That's why it is very important to maintain temperature between 105 to 110 degrees centigrade. Very good. Okay. What is flow index?
Slope of flow curve in liquid limit test.
Yes, in the liquid limit test, as I have said previously, this is the flow curve, and flow index is of the flow curve. That is, if this flow index is IF, then slope means change in y by change in x. This is from W1 to W2. It will be W1 minus W1 minus W2. Initially is more, finally is less. That's why divide by log to the base 10 N2 by N1, because the x-axis is in logarithmic scale. Okay, so this is the flow index. This is the value of flow index, slope of the flow curve in liquid limit test. Good. In a wet soil mass, air occupies 1/6 of its volume and water occupies 1/3 of its volume. The void ratio is, what is the answer?
So don't know.
Don't know. Okay. If air occupies 1/6 of its volume, let the total volume be V. So air occupies 1/6, that is VA. Be how much? V by 6. Water occupies 1/3, that is VW. Give us how much? V by 3. If we add VA and VW, what will we get? VV, right? Volume of voids. Because the void will contain only air and water. If there is no water, then it will be air. So it will be V by 6 plus V by 3. What will you get? After adding 1 by 6 and 1 by 3? 3 by 6, that means half, right? Will you get V by 2? Isn't it?
Yes, sir.
We'll get V by 2. We'll get V by 2. So if volume of void is V by 2, then volume of solid is V minus V by 2. That is V by 2, isn't it? So we have got the volume of void, we have got the volume of soil solids. Then what is the void ratio?
VV by V.
VV by Vs. So what is the answer?
1.
Yes, 1. Is it clear or should I explain again?
It's clear.
It's clear, yeah. So this is 1. The void ratio, go by the definition, volume of void by volume of soil solids. You will get the answer. Okay, next question. A soil deposit has a void ratio of 1. If the void ratio is reduced to 0.6 by compaction, the percentage loss in volume is. Any answer?
No, sir.
Okay. Again, we will go by the definition of void ratio. Okay. So, I'll just divide these two cases, initial and final. Initial void ratio, suppose E0 it is equals to 1. Reduced to, that is the final void ratio, EF equals to 0.6. In initial case, volume of void by volume of solids is equals to 1. Means volume of void equal to volume of soil solids. Let volume of void equal to volume of soil solids equals to V. Okay. Then total volume Vt, it will be how much? 2V, right? Isn't it?
Yes, sir.
2V. Okay, in this case, volume of void by volume of solid equal to 0.6, or if we say that the volume of soil solid is V, if we replace Vs by V, then volume of voids is equal to 0.6 V, isn't it? 0.6 V. Then total volume is how much? Volume of solids, that is V plus 0.6, that means 1.6 V. Clear?
So please explain the last
Yes.
PV.
Yes. See, if the void ratio is changing, volume of solids won't change, right? Volume of solids, will it change? No. Answer the question. Will the
No,
volume of
sir.
solids change? No. So I can put a constant for the volume of solids. Let the constant be V. Volume of solids of the soil is V. So in this case, Vs equals to V. And since void ratio equals to 1, Vs equals to Vb equals to V. Isn't it? So Vb is also equals to V. Vs
Yes, sir.
also equals to V. Total volume is 2V. In this case, Vs equals to V. So Vb equals to 0.6 V. Isn't it? Because Vb equals to 0.6 Vs. And 0.6 Vs
Yes, sir.
means 0.6 V. So if I write total volume, that is total volume means volume of solids, that is V plus 0.6 V. This is means V plus 0.6 V, isn't it? Because V is the volume of soil solids and 0.6 V is the volume of void, isn't it?
Yes, sir.
Now it is clear?
Yes, sir.
Is it clear, or should I explain once again? I think it's not clear.
So it's clear.
Yes. So this is the total volume we have obtained by adding the volume of soil solid, which is constant in both the cases, and the volume of voids, which has been changed due to compaction. So when void ratio is changed by compaction, what do we mean? We mean what is changed? The volume of void is changed, isn't it? The solids won't change, right? So volume of voids has been changed from V to 0.6 V. Total volume is 1.6 V. Percentage loss in volume. Loss in volume means the entire volume of soil mass percentage loss. What is the loss in percentage? That is 2 minus 1 points. It is 0.4, right? If we say volume loss, that is initial minus final, 2 minus 1.6, that is 0.4 V, right? Isn't it?
Yes, sir.
Yes. So percentage loss means, if it is in percentage,
40%.
why 40%? Percentage means loss by initial volume by into 100, right? 0.4 V is the loss. What was the initial volume? 2 V, right? Can you follow?
Yes, sir.
Initial volume is 2V. So cancel out VV, 2 into 0.2, 0.2 into 100, that is 20%. Is it clear?
Yes, sir.
Is there any doubt regarding this question? When you find out the percentage loss, you find the percentage loss with respect to the initial volume, right?
Yes, sir.
If you have at the beginning of the day you have 40 rupees, at the end of the day you have 20 rupees. How much you have spent? 20 rupees, right? Percentage spent is 20 rupees out of 40 rupees initial amount in the day, right? So this is the same in every percentage loss or percentage increment. We are going to calculate on the initial value. So 0.4 divided by 2. Okay. Okay.
Yes, sir.
Next question. Which of the following is constant for a given soil? Very easy question. What is the answer?
Unit
What?
of solid.
Unit of soil solids. Isn't it? That was the answer, right?
Yes, sir.
Yes. Because bulk unit weight is what? Bulk unit weight. Bulk unit weight is weight by volume. Soil solid is weight of soils, dry weight by volume of soil solids. What is dry unit weight? Dry weight by total volume. What is saturated unit weight? Weight of saturated soil by volume. Now tell me, why will it be constant?
It will remain size of particle, bulk and other can change volume.
Your voice is breaking. Just tell me in brief. Hello.
So in case of unit weight of solids, only the solid its weight and constant.
Yes, I got it. I got
Bulk
it.
unit.
Yes, I got it. You are trying to imply that this Vs, everywhere we have V as the denominator. See, here it is V, here it is V, here it is V. V means total volume of the soil with respect, also including its voids. Now the voids might change because there can be compaction, there can be increment in water percent, whatever it is, but volume of soil solids won't change, right? So in this case, it has the weight of the dry soil mass, soil solids. Also, the denominator is more important because it has the volume of the soil solids. You see, in the numerator we also have WD in here, dry unit weight. Okay, but here we have V in the denominator, but V will change, right? Here Vs won't change. So this unit weight of soil solids is constant for a given soil. Clear?
Yes, sir.
Yeah, good. Find the porosity of a soil whose void ratio is 0.5. What is the answer?
0.30.
Yes, 0.3333. Why? Porosity is N. N is equals to E divided by 1 plus E. Isn't it? N is equals to
Yes,
E
sir.
divided by 1 plus E. So, just a minute. Just, yeah. N is equals to E divided by 1 plus E. So if you put 0.5 over 0.5 by 1 plus 0.5, you get the value of 0.333. For a soil in its natural state, the void ratio is 1, water content 30%, specific gravity is 2.5. The decay saturation percentage is, what is the answer?
75.
How do you calculate it? How do you calculate
2
25%?
G is equal
Yes.
to formula W into E.
S equals to WG by E, right?
Yes, sir.
Yes. S equals to WG by E. this case, if W is 30%, it is 0.3, G is 2.5, and E is 1. 0.3 into 2.5, that means you get 0.75 or 75%. Good. Next question. Theoretically, the void ratio in soils can have the following values. Which is the answer?
So less than 1.
Wait. Void ratio can have any values less than 1. Why less than 1?
So how it can be in any type of Actually,
It, you are saying it can't be more than 1.
yes.
Okay, we'll just see. So what is the definition of void ratio? Volume of void by volume of solids. Okay. Can you actually define the volume of voids if you have a what to say petri dish and you have a soil sample? If you say the entire volume of petri dish is a soil sample, can you actually define the volume of voids in that sample? Suppose you
No,
have
sir.
suppose you have a silty clay soil, and you put the soil sample in a petri dish to do some experiment. Can you actually define the entire the entire volume of voids? That this particular this force in between this petri dish, in between this soil particles are the void. I'll be counting that. No, the external volume can also be a volume of void, right? That's what happens
Yes, sir.
when you go on adding water and water and water. Then what happens? The volume of voids, if we say we are going to add water, okay, you are going to add water in a soil which is not having any particular shape, we're just adding on water to any particular soil deposit, okay, then what will happen? The volume of voids, will it remain constant?
No, sir.
Volume of void will not remain constant on addition of water, on definition of a different space, okay, different domain of the soil experiment. This volume of voids can anytime be more than the volume of soil solids, because see, I'm considering this to be our volume, okay, this is a box, this is the volume. Now we have a soil solids like this and this, suppose. Isn't the void isn't the void having more volume than the soil solids? Hello.
Yes, sir.
Yes, in this case, in this domain, the volume of void is more, right? So it is up to us how we are going to define the space and geometry of the sample. So for that case, volume of voids can be more than the volume of soil solids at times. At times, volume of voids can be more than the volume of soil solids. Okay, so when the volume of void is actually more than the volume of soil solids, then we can say that the void ratio of the soil has exceeded 1, isn't it?
Yes, sir.
And in general case it will be more than 1 also, so it can have any value less than or more than 1. Now there comes a catch. This will have a particular restriction for porosity. Why? Because porosity, in case of void ratio it is this, in case of porosity it is what? It is volume of void by total volume of the soil. That means this volume of void which is present over here, this void, divided by the entire volume. Now the volume of void will be obviously more less than the entire volume, right? Because the entire volume is considering soil solids and the voids, isn't it? So porosity will be always less than 1 or less than 100%. Porosity always less than 100% or less than 1 as a fraction. But void ratio can be more than 1 or less than 1. Clear?
Yes, sir.
Yes, good. This question have you solved?
No, sir.
Okay, it's very easy question. See, just go by the definition. So mass was 18 kg, volume is this. Okay, so what is the density? Mass by volume. Okay, so density initially, before the addition of 0.02 kg of water, initially density rho 0 is 0.18 by 10 to the power minus 4. I think you will get 1800, right? 1800 kg per meter cube. And we have dry density equals to how much? 1600 given. Now I have told you the formula. Dry density or dry unit weight equals to bulk density by 1 plus W. So W equals to how much? Bulk unit weight divided by dry unit weight or dry density minus 1. And in this case, the final value of this will be 0.18 plus addition of 0.02 kg of water, that is 2 kg of water divided by 10 to the power minus 4, that is 2000 will be, right?
Yes, sir.
It will be 2000 kg per meter cube. In this case, the water content will be rho F by rho D minus 1. So rho F equals to 2000 divided by rho D equals to 1600. The answer will be option number B. You can solve, you can find out 12.5 and 25. Isn't it? Solve 1 and 5 and tell me the answer. What is the answer? Have you got the answer?
So I'm calculating.
Yeah.
So it's
How much?
5.
0.25. Hello?
0. For first.
0.125. Yes, 0.125 in percentage it will be 12.5, right? Can't you follow? Hello, Vaishnavi.
Yes, sir.
Yes, can't you follow?
At the 0.5.
Yes, it is 0.125. That means in percentage it will be 12.5. And the next one will be 0.25. That means in percentage it is 25 percentage. Isn't it?
Yes.
Yeah, that's it. That's all I wanted to hear. Okay, good. Next question. A particle size distribution curve with a flat portion represents. What is the answer? Yes. Hello.
Gap.
Gap graded. Yes, gap graded soil, because it means some particles are absent. See here, particles from this and this are almost negligible. You see, percentage finder is not incrementing in this percentage. So this kind of these particles of size is almost absent over here. Yes, flat portion means gap graded soil. Now, have you solved this question? The last one.
No, sir.
Okay. So I'm asking about the specific gravity at first, isn't it? Specific gravity, what is the definition? Density of soil solids by the density of water. What is the density of water? 1 gram per cc, isn't it?
Yes, sir.
So the units over here is in gram and cc. So if we find out the density of the soil solids, we can get the answer, right? So first of all, find out the volume. What is the volume? Volume of cube. It is a cube. So 5 cube, that is 5 into 5, 25 into 5, 125. Isn't it? The volume of the sample is 120, 125 cc. Clear? First step. Is it clear?
Yes, sir.
Yes. What is the mass? Dry mass. The mass of the dried soil is 135 35 cc. Now, when the soil mass is saturated, the mass becomes 195. So after saturation, the mass is how much? 195
90.
cc. So if the dry is this one, saturated is this one, what is the mass of water? What is the mass of water?
60.
Yes, 60 gram. If the mass of water is 60 gram and density is 1 gram per cc, what is the volume of water?
60.
Yes, it is 60 cc. If the volume of water is 60 cc, okay, then in the dry condition, this volume was not present, right? This volume was present, but there was no water, isn't it? This is the volume of void, right? This is actually the volume of void, isn't it?
Yes, sir.
Because saturated condition there is no air present, so it is only water. So volume of void is volume of water 60 cc. 60 cc. Now tell me what is the volume of the soil solids then?
5 minus 6.
This is the volume of the soil, total volume. Okay, so volume of solid is how much? Total volume minus volume of the, I'm sorry, not the
Void.
mass. I was first telling about the mass, but not the mass. It is the volume. 125 minus 60, right?
Yes, sir.
Yes, so it is 65. 65 cc. Now, what is rho s? Md by Vs, right? Mass of dry soil divided by volume of the soil solids. Now calculate and tell me the answer. Mass of dry soil is 135 and volume of the soil solids is 165.
2.0.
2.077, right? The last option we can say, isn't it? Clear?
Yes, sir.
Yes. So now the next question, it became easier. What is the void ratio? Void ratio means volume of voids by volume of soil solids. What is the volume of void we have calculated?
60.
What is the volume of soil solids we have calculated?
65.
Now tell me the answer.
0.923.
The last option, right?
Yes, sir.
Yes. So is it clear? This numerical it is clear to you? I hope.
Yes, sir.
Okay. Any doubt regarding this session?
Oh, sir.
Okay. So if there is no doubt, I believe I can end this session. I hope this session was useful to you. It was quite an interactive session. You got to know some questions and concepts from this session, right? It was
Yes,
useful to
sir.
you? Okay. The only thing which you have, you couldn't solve the tough numericals, some tough numericals. I hope you understood all of those and the concepts behind them.
Yes, sir.
Okay. Thank you for attending the class. We'll be meeting on next Sunday at 5 p.m. Okay.
Okay, sir.
Yeah.